Hello and welcome to yet another video of Cornerstones of Math. Today we are going to solve the following problem. Consider a graph of y equals absolute value of x over 2 defined on real numbers. Consider rotating this graph counterclockwise about the origin so that the negative x part of the original graph overlaps the x-axis. Express the new graph with a single equation. Alright, let's get straight to the point. The rotation matrix. Suppose that the angle of rotation is theta. Suppose that the point x, y on the original graph moves to x prime, y prime by rotation. Then point x prime, y prime in a column vector notation is given as the rotation matrix r theta times the column vector of the original point x, y. And the rotation matrix is given as cosine theta minus sine theta, sine theta, cosine theta. So this is the basic theory, but here's the thing. X, y is on the original graph, which satisfies this equation. However, we want to find the equation of the rotated graph, which is the relation between variables x prime and y prime. In order to obtain that relation, we must use the given relation between x and y. Therefore, we express x and y in terms of x prime and y prime using the inverse of the rotation matrix. And the inverse of the rotation matrix is just r minus theta, which is pretty obvious, which gives cosine theta sine theta minus sine theta cosine theta times x prime y prime. And we can easily find the trigonometric values of this angle theta. You see, this part of the graph has a slope of minus 1 over 2. And since theta is between 0 degrees and 90 degrees in this case, we can simply draw a right triangle here to find out that cosine theta equals 2 over square root of 5 and sine theta equals 1 over square root of 5. Therefore, xy is given as matrix 2 over square root of 5, 1 over square root of 5, minus 1 over square root of 5, 2 over square root of 5, x prime y prime, which gives 2 over square root of 5x prime plus 1 over square root of 5y prime and minus 1 over square root of 5x prime plus 2 over square root of 5y prime. And this x and y satisfy the equation of the initial graph y equals absolute value of x over 2. So substituting into this equation gives minus 1 over square root of 5x prime plus 2 over square root of 5y prime equals 1/2 times absolute value of 2 over square root of 5x prime plus 1 over square root of 5y prime, which simplifies to minus 2x prime plus 4y prime equals absolute value of 2x prime plus y prime. So this is the relation between x prime and y prime. However, x prime and y prime are variables we have introduced, so we can distinguish them from x and y, satisfying the original equation. But generally, we use x and y for any graphs on the coordinate plane, and what's important is the relation, not the type of variables. So we switch to generally use the variables x and y, and write absolute value of 2x plus y plus 2x minus 4y equals 0. And this is the equation of the rotated graph. But we can think of another way. You see, these types of functions are called piecewise linear functions, as they consist of several pieces of different linear functions. And some of you might remember that these type of functions contain absolute values in their equations. For our case, the function has only sharp point at x equals 0, so it must contain a times absolute value of x term in its equation. And in order to have only linear pieces, the rest of the equation can only have linear terms maximum, which we can write bx plus c. This is the general equation of the piecewise linear function having sharp turn at x equals 0, and let me show you that using this equation leads to the same answer. Really? Well, let's find out. First, let's consider the case where x is negative. Then the function becomes y equals minus ax plus bx plus c. And this has to be the same graph as this, which is y equals 0. So by comparing, we have a equals b. Also, since the graph passes 0, 0, we have c equals 0. So by these two relations, now we have y equals a absolute value of x plus ax. In order to find a, we need one more point on the rotated graph. So let's just rotate this easy to find point 2, 1 on the original graph. Then the rotated point is, this time just the rotation matrix r theta times vector 2, 1. So cosine theta minus sine theta, cosine theta, 2, 1. So we have the matrix 2 over square root of 5 minus 1 over square root of 5, 1 over square root of 5, 2 over square root of 5, vector 2, 1, which will give 3 over square root of 5 and 4 over square root of 5. So the rotated graph passes 3 over square root of 5, 4 over square root of 5. So from this equation, we have 4 over square root of 5 equals 3 over square root of 5a plus 3 over square root of 5a, which gives a equals 2/3. Now, if you really don't want to use the rotation matrix, then you can use the fact that the rotated graph forms angle 2 theta with the x-axis. So if you calculate the values of cosine 2 theta and sine 2 theta using trigonometric formula, then you will be able to find a point on the rotated line by selecting any positive real number r and using these coordinates. So using this value of a, we have the equation y equals 2/3 absolute value of x plus 2/3 as the rotated graph. But wait, in the previous method, we have obtained this equation. So how can there be two equations representing the same graph? Well, first, let's take a look at equation 2. Using the case division for absolute value, it is split into y equals 4 over 3x if x is positive or 0, and y equals 0 when x is negative. So let's show that equation 1 gives us the same result as this. When we are dealing with equation 1, we must split cases like this. We have absolute value of 2x plus y, so we must divide the case as first when 2x is greater than or equal to y, and then when 2x is less than y. For the first case, 2x plus y just comes out from the absolute value, so 2x plus y plus 2x minus 4y equals 0. And for the second case, then we have minus 2x minus y, so this plus 2x minus 4y equals 0. So now the boundary for the case division becomes this line y equals 2x. The first case is where y is less than or equal to 2x, so below this line, then you can see that the equation becomes y equals 4 over 3x. So below the line y equals 2x, we have the graph of y equals 4 over 3x. And for the second case, that is, above this line y equals 2x, then you can easily see that the equation becomes y equals 0. So above the line y equals 2x, we have y equals 0. Here you can notice that the domain of each part coincides with x greater than or equal to 0 and x less than 0 respectively. That is, using equation 1, we can indeed end up with the same graph as in equation 2. Two equations indeed give us the same graph. And that's all for today's video. Thank you for watching, and I will see you in another video.